In example 15, I wish to explain this example because we are told that show that sine x minus root 3 cos x can be written in terms of r sine x minus alpha. Hence, part B, sketch the graph of y is equal to sine x minus root 3 cosine x. We have seen in the previous example that we start expressing this part because we are familiar with this addition angle formulae, whereby sine x minus alpha can be written as sine x cos alpha minus cos x sine alpha. And now that there's an r multiplying from outside, then r appears in both terms. So we have r sine x cos alpha minus r cos x sine alpha. And if we have been able to express the right hand side this way, then this part now, this new expanded part, is equals to sine x minus root 3 cos alpha. Therefore, what we had originally, which is sine x minus root 3 cos x, can now be equals to what we have acquired after considering this using addition angle formulae. That means sine x minus root 3 cos alpha is equals to r sine x cos alpha minus r cos x sine alpha. This is addition angle formulae. You will see it on page 71 explained. Now, when we consider the left-hand side versus the right-hand side, the sine x has to be equals to the term that is bearing sine x on the right. And sure enough, r sine x cos alpha is equal to sine x. So if you divide by sine x on both sides, on the left-hand side, you're going to have 1, and this way we're going to have r cos alpha is equals to 1. So at that point, we can see r cos alpha is equals to 1. So the second term that is having cos x has to be considered to be equal the other term on the other side that is having cosine x. And we are simply saying that negative root 3 cos x is equals to r cos x sine alpha. So divide both sides by negative cos x and negative cos x, so that this negative and this negative cancel out, that negative and that negative cancel out, and you are left with a statement that is telling us r sine alpha is equals to root 3. And we know that sine alpha over cosine alpha, which is also equals to root 3 over 1, can be expressed in terms of tan alpha, because sine alpha over cos alpha, which is tan alpha, is equals to root 3 over 1. So we are convinced that there's an angle somewhere whose tan is a root 3. So if we have a root 3, then we can only talk about shift tan answer that gives us 60 degrees, and 60 degrees is actually pi over 3, because our question is in radian form. So we have to stick to that. Pi over 3. And now that we have considered tan alpha to be equals to pi, to be equals to root 3, and this is going to be root 3 over 1. So if we draw this triangle, we can also bring it here, and we say pi over 3 is opposite over adjacent according to SOHCAHTOA. And that opposite is root 3 and adjacent is 1. So let us just see. If we use the Pythagoras approach, then we are saying r sine alpha squared, which is r squared sine squared alpha, plus r cosine alpha squared is going to be equals to 1 squared plus root 3 squared. And what is this? Because r squared is common, then we're talking about opening the bracket, sine squared alpha plus cosine squared alpha is equals to 1 squared plus root 3 squared, which is 4. We all know that sine squared anything plus cos squared anything, or rather, let's just be specific. Sine squared alpha plus cosine squared alpha is equals to 1. So r squared times 1 is 4. So what is r? Root 4. And because r is greater than 0, so it can only assume the positive value of root 4, which is a 2. Hence, part A, now that we have the value of r and we have the value of alpha, hence sine x minus root 3 cosine alpha is equals to r, which is 2 sine, open bracket, x minus alpha, because our alpha is pi over 3. And that is just part A. I've done it quickly because we have looked at such questions before in example 14, and it's not a problem to any one of us. Part B, we are told that, hence, sketch the graph of y is equal to sine x minus root 3 cosine x. Yet now we know y is equal to sine x minus root 3 cos x. It is now equals to 2 sine x minus alpha. So we are supposed to sketch this graph, which is now this. And because they are using the word hence, then we are expected to use the results of part A to solve part B. So the y is equal to sine. You can see, if this is our new graph, the graph you are expected to sketch, you can already see that it must be coming from the graph of y is equal to sine x. It is the graph of y is equal to sine x which has been transformed. And how has it been transformed? If you look at this, there is addition inside and there is multiplication outside. Let us first of all take care of the addition inside. Addition inside, according to Mayo, and I believe all of you remember Mayo, addition inside, according to Mayo, is horizontal translation of negative a steps. Horizontal translation of negative a step. Incidentally, our a here is negative pi over 3. So, horizontal translation of minus negative pi over 3, which is actually positive pi over 3, because a minus followed by another negative is positive. So, it is a horizontal translation of pi over 3 steps. What does that mean? All x values, because anything to do with the horizontal only affects the x values and never the y values. That means all x values move to the right pi over 3 steps. Before we do anything, let us have the graph that is going to be transformed. The graph of y is equals to sine x. When x was 0, sine 0 is 0. When x is pi over 2, or rather 90, sine pi over 2 is 1. When x is pi, 180 degrees, the value of y is 0. When x is 3 pi over 2, or rather 270 degrees, the value of y is negative 1. And when x is 2 pi, the value of y is 0. This is the graph of y is equal to sine x. If we effect this with the first transformation, x values move to the right pi over 3 steps. We start with this original step. X was 0, so it will move pi over 3 steps. So y will be 0 when x will now be pi over 3. We come to this step. Y here was 1 when x was pi over 2. When x was pi over 2, we add a third pi, and now y will be 1. Pi over 2 plus a third pi is 5 pi over 6. X was 0 when pi was when y was 0 when x was pi. It is now going to be 0 when x is pi plus a third pi, which is 4 pi over 3. And so on and so forth. X was -1 when pi was, or rather, y was -1 here when x was 3 pi over 2. 3 pi over 2. And now, if you add a third pi to this one, you're going to have 11 pi over 6. So y is supposed to be -1 when x is 11 pi over 6. And y was 0 when x was 2 pi. And now, because it has moved to the right pi over 3 steps, y will still be 0, but this time x is going to be 7 pi over 3. That is the first transformation. The second transformation now upon this one is going to be multiplication outside. You can see multiplication outside. Now that we have transformed this to this, it is this one that is going to undergo multiplication outside. Multiplication outside, according to Mayo, means multiplication outside means vertical stretch of a steps. A step means our a here is vertical stretch of scale factor 2. If we are talking about vertical stretch of scale factor 2, it means all y values multiplied by 2. And at that point, we can even talk of bringing this graph to, this is negative, positive 2. This was 1, it comes there. This one's whatever, it comes here. This one is 0, it remains there. This is -1, it becomes -2. This is 0, it remains there. This one was whatever. And we are going to come up with a graph that may look like this. That may look like that. And this is actually the graph we have down here. This is the graph we have down here. This is the graph we have down here. Now, the maximum value of y is 2 and the minimum value of y is -2, just because this graph has undergone vertical stretch of scale factor 2, and that is just like it. So it is important to note that this question had two important parts, and now that we've been able to express the first part and also sketch the graph, please note and don't forget the Mayo thing, the Mayo table. You are not new to Mayo, please make use of it. All right?